Hello everyone, welcome back to my channel, and this is the video which we are going to solve for the different rows in the Pythagorean theorem. Now if you clicked on this video and you really have no idea what the Pythagorean theorem is and what it looks like, I will have a link to the previous video right now on the screen. That way you guys can go check that out. I did a brief recap of the simple algebra 1 statistics on the Pythagorean theorem and how to solve for the rows of the Pythagorean theorem, yet we're going to find another more mathematical way to solve for the Pythagorean theorem, which is a little bit more complex, but in algebra 2 we try and make ourselves a little bit more difficult because we like to challenge ourselves as much as possible. So now we're going to be using the combination equation, which is present in the algebra 2 book because that was its own chapter on probability, so make sure you go check that out. At least have some brief knowledge on the chapter, or else you will be completely confused with. Hello everyone, this is the problem for the day. We will do another bonus problem at the end of the video. I like to keep my videos nice, short, and sweet, so that way I don't overpower you, but if you guys have any specific questions, leave them in the comment section below, and I'll be sure to work them out with you or help you with that problem in case you aren't getting it still and you need a further description on the problem. But these take a little bit longer, and that's why I'm not doing that many of them, but they're not that difficult, so let's just jump right in. So this says x plus y to the fourth. Now we are going to solve for the fourth row in the Pythagorean theorem. Now you look at this problem and you need to somehow get numbers, and you're like, okay, there's no x numbers or y numbers, but it's to the fourth, 4x, 4y. I mean, you don't even know what's going on. I mean, it'd be x to the fourth and y to the fourth of anything, and you're just kind of like, what in the world? Not 4x, 4y, but to the power of 4 because it is the exponent. So what we are going to do is we are going to use our wonderful combination numbers, and I'm going to show you as to how we are going to do that. So first off, you're going to take that 4 and you're going to write it down. Here's our 4. Next, we're going to put our lovely c in the combination initial, and then we're going to put that 4 again. And just by looking at our exponent, that's how many spaces you're going to have. So just add your pluses. That way you don't get thrown off at the end. So we have 1, 2, 3, and 4 spots because that is to the fourth power. Now we have 4c4, and we're just going to work with our c's. That way I don't throw you guys off. So each of them are going to start with 4c, no matter what. It's going to start with this non-changing number. So our first number will never change. It'll always be the number of the exponent. Now the number that goes into this place, which I haven't filled out yet, is going to start to decrease each time. So instead of 4, it'll be 3. Instead of 3, it's going to be a 2, and then a 1. As you can see, it's 4, 3, 2, and 1. So now that we have that, we're not done because we have to add our x's and y's to this. So our first little line here will never have a y, but it will always have an x. So no y, but x. So that's just a little side note for you guys. That way you guys remember there'll be an x here, but no y, and you'll start your y's there, and there. So no y here, but y, y, y. And we will have x's in all of them. Whoopsies. Alright guys, so our x power is going to be the same as the power that's right here. So I'm going to use a different color to kind of show that for you guys. So our exponent for our x is going to be the same as the number here. So you see that 3 that we wrote there? We're just going to circle that. We're going to write our x, and then we're just going to write 3 because that's that number. And we're going to keep doing that. So we have 2 and 1. Our x is going to be second, and our x is just going to be x because x to the 1 is the same thing as x. It's very simple. Now, we have to add y's for these ones, and because those numbers stay the same and they are decreasing, our y's are going to increase. So because there's no y in this one, they're going to start here, here, and here. So that's going to be y to the first, and that's going to be y to the second, and that's going to be y to the third. And so we just have y1, y2, y3, and then we have x to the fourth, x to the third, x to the second, x to the first. And that is how you partially solve the problem. Now we cannot leave it in our C form because if you look at the Pythagorean theorem, it does not have C's in it. So you need to use your handy dandy scientific calculator and solve the combination equation that way, or you can do it yourself. Now I'm going to show you without using a calculator how to do these because they aren't large numbers. And let's say for some reason you forgot your calculator. This is another tactic you can use, which you probably already learned in the previous chapter, which was the conics and probability chapter. Alright everyone, so 4C4, how are we going to solve that? Obviously 4 over 4 is going to be 1. How did I know that? Because we have our two numbers. Okay, so I'll rewrite it right here, that way I don't start mixing up our equation. So 4C4. Alright, so what we're going to do is we're going to take this number and put it over the sum of that number minus that one times by that one. So 4 exclamation mark over 4 minus 4 exclamation mark 4. And in the combination equation we always put this number again at the end. And in case you guys want to know a little bit more about this, let me know and I can always do a video on it. But the exclamation marks mean the continuation. So it's 4 times 3 times 2 times 1. So 4 times 3 times 2 times 1 all over 0, because 4 minus 4 is 0. So you don't have to do anything with that, but we do have that continuation there. So 4 times 3 times 2 times 1, and they all just end up crossing out, so equals 1. Now let's say we're doing 4C2. So 4C2. So we're going to put our lovely 4 up top, and then we're going to do a line, and then parentheses 4 minus 2, as you can see here. And then we are going to do 2 again, as I said previously, because our 2 is here, and we always put that number again at the end. So now it's the same thing. It's 4 times 3 times 2 times 1 all over 4 minus 2, which is 2, exclamation mark, which is also the same as 2 times 1, and 2 exclamation mark again, so the same thing as 2 times 1. The 2 times 1 cross out, 2 goes into 4 twice, so you're left with 6. So you can easily do this mathematically here, or you can do it through your calculator. You will get the same answer every time. Just don't forget to write your x's and y's whenever you do it, because that is also very, very, very important. So that is it for this video. Now I did say I was going to do an extra video, and I will actually, not extra video, but an extra problem, and I will post that on my blog, which I will leave down below, and also put a link right now on the screen, and I will have some more practice problems on there with the answers and work. That way I don't overwhelm you with the length of this video, and we can get into some more math shortly. Alright, I hope you guys enjoyed this video and found it helpful some way, and that is just how you solve a row of the Pythagorean theorem.